Hello viewers, heat and temperature question 4. We have 4 litres of water which is at 10 degrees Celsius initially, and it's mixed with 1 litre of water at 75 degrees Celsius. We need to find the final temperature of the water provided it is thoroughly mixed. So all of the 5 litres of water that we end up with are at the same temperature. There's no cold pockets and there's no hot pockets anywhere. Okay. So with the cold water is at 10 degrees and the hot water is at 75 degrees. So let's look at on the left hand side of the equation the cold water, and on the right hand side of the equation the hot water. All of the heat energy that was in the hot water must go into the cold water. So the gain in energy of the cold water must be the same as the loss in energy of the hot water. So the formula we'll use here is Q equals mc delta T. It's a temperature change. It is not a phase change. We can guarantee that the final temperature will be somewhere between 10 degrees and 75 degrees. So none of the water is going to melt. It's all liquid and it's going to all stay liquid. So for the cold water, it's a gain in heat energy. So it's going to be M is the mass. The cold water is 4 litres. Since we're dealing with water, 4 litres is 4 kilograms multiplied by specific heat of liquid water multiplied by the change in temperature, which is going to be final temperature is T, which will be the temperature of the mixture that we're looking to find here, minus the original temperature, which is 10 degrees. And for the hot water, this will be a loss in heat energy, so we'll put a minus at the front. Now we've got the mass of the hot water, 1 litre. Since it's water, that's 1 kilogram, multiplied by C, which is the specific heat of water, multiplied by the T, which is again the final temperature of the mixture, minus the initial temperature of the hot water, which is 75. Okay, so C on both sides is the specific heat of liquid water. That will be the same. That is 4184. For both sides, so we can just divide both sides by C. So therefore, we get 4 times T minus 10 equals, with dividing out that C. Also, I can absorb that negative sign out the front by changing the order of a subtraction. 5 minus 2 would be 3, but 2 minus 5 is negative 3. So switching the order of a subtraction would make the whole thing negative, which means I can absorb that negative sign by doing that. So we've got 1 times, let's not even write that, so we've just got 75 minus T once we've switched the order of subtraction like we said that we were going to. Okay, so therefore we've got, if we multiply the 4 into this bracket, we get 4T minus 40 equals 75T, and it's a matter of solving that equation for T. So if we add T to both sides, we'll get 5T on the left equals, add 40 as well, so we get 75 plus 40, which is 115, and dividing by 5 tells us that T equals 23, so the final temperature of the mixture is 23 degrees Celsius. Okay, thanks for watching, over and out.